Alright, and we are back. So, as previously noted, things we need to achieve at this point is make this a little bit bigger so that this top bolt does not have any problems. One of those things, we could change the bolt pattern, but it seems to me one way or another we'll end up with bolts towards the top edge, which is where we're running into this issue. I did not address that last stream, so just wanted to get that out of the way. And then after that, obviously, we just finished up doing this wall, toss the mounting holes for the micro switch, and then mount it to the extrusion. So let us go ahead and get started. So we want to start from the top, and it's one of these things. We've got a 3mm wall right here, 3mm offset on there. So basically my thought is that if we make sure that that 3mm is above this ring right here, we should be good. Control Z, I accidentally moved it. What that entails in that case, I believe, is we just need to shift this up by 3mm. So actually, I guess because that's a tangent right there, we are going to have to do a little bit of juggling, just because when you switch planes in Fusion, it doesn't generally work out terribly well. This is shaft handle, yeah. So right there, and actually I should enter this. Oh, evidently I misfiled this one. Okay, top of shaft handle mounting flange. And actually at this point, alright, it's going to end up on the top level as well, because the center shaft we're building off of a sketch we didn't start the component first. This is one of those things where sometimes I feel like I'm doing things unnecessarily, which is why in this design I wasn't creating components first. I was doing sketches. Everything was a sketch and then extrude into new component is how I handled this design. And this is one of those reasons why maybe I shouldn't do that. So good to keep in mind. Go back to doing component first and then sketches. One of those things. It's an extra step, which is why I didn't do it, but when we run into situations like this, that is where it becomes a little bit wonky. Now, you see how this turned into a green line? That is what I was talking about juggling. This is going to be top of center shaft. Turn it off. So it turned into a green line because it has no idea what the heck we're talking about at this point, unfortunately, and there's no update, whatever you call it, redefined projections, I believe is what it's called. There's no menu there to reset this. So what we got to do at this point is A, make sure we get the right line, which I'm hoping is that one. It looks like I was right. And B, just reproject it and realign it. This becomes a bit of a problem when your design is much more complicated, which is why it's well, yeah, it is what it is. It's what it comes down to. It is what it is. All right, now if we come forward in time, let's take a look at it. Okay, I do have to fix that though. That would be this guy right here. And I want to instead throw my own circle in here because we're no longer using that circle, and use that one instead to round it off. This guy. Unselect all that and just grab the corners. Again, we're no longer following the contours of that. We are just well, we're offsetting the contours of it at any rate up top. Now let's get the handle shaft out of the way. Let's see, that is okay. That is orange down there. That's good. I want to double check that before I started closing this stuff up and turning them off. So let's turn both of these out and hop into the center shaft. And I know I just turned this off, but let's double check really quick, just visually. So it looks like we actually do want to go down a bit further. in order, because this head size right here is about the same size as the bolt, or as the nut. And then we want actually some more on top of that, with some more space beyond that as a wall. So in that case, we will, at this point, it's a bit easier because we've already changed the projection, or the plane that it's on, the sketch plane. So now we can just go up. I'm guessing it's going to be 8 is what I'm guessing. Oh, okay, never mind. Let me remove this really quick. Yeah. That's what happened there. This guy needs to move down at this point. Or no. I was thinking this had to move down, but I could be... Let's see. There it is right there. Yeah. Yeah, okay. So we want to lower that. So let me look at how we're defining this wall really quick. There's that. How do we grab a new component? Let me figure out where is that the same sketch right there? That might be the same sketch right there, in which case I actually shouldn't have turned that off. I should have left that on. Okay, this guy should, instead of being 3 millimeters from that, be 3 millimeters from that is how that should be. No, that's not gonna work. Okay. Yeah, okay, I recall this now. Because I said, oh, this should actually be 3 millimeters from there. Okay. Okay. So... let's see. Alright, I'm gonna throw one more in here because this shouldn't be tied. This circle's offset shouldn't be tied to this guy right here. It should be tied to the wall. So we're going to do that. And now do that 3 millimeters. So that is now more correct. We now want that tangent to that. And then the last trick here is these concentrics, which is going to be a bit messy because it's going to be hard to tell which is which and which concentric. Actually, I should probably just, yeah. I am going to delete them all and put them all back together separately. So that's that. And those are my 3 millimeters, so that's fine. And actually, at this point, so this concentric right here. Okay, that is that guy right there. Good. Want to make sure I understood where that one was. This guy does want to be concentric. Does he want to be concentric? So technically speaking, so this is my cut, the one that rounds the corners. It does want to be concentric to the other guy, I believe. So I will put him back concentric. The other thing would be just to tangent him in, but I believe it is more correct to make him concentric. That way he follows the outline. That was the idea. And then, is there anything else here that I lost concentricity from? Let me turn off some bodies really quick. I have... Okay, there's just that. That's fine. And by fine, I mean it's acceptable. We can fix this like this. And then it's just the height. And otherwise, this is the only thing that's unconstrained right now. Alright, if this is the only thing that's unconstrained right now, then that is fine. So we are going to go ahead and, well, Control Z because that got me too close. But what I wanted was to get at least below the edge here. And then this outside one should go tangent to the top. And now let's turn the bodies back on. Door still fits inside. Now let's turn the handle shaft on. And the handle shaft I think we might be, it's a little hard to tell, so the handle shaft should be 3 millimeters from here. Let's check really quick. Yeah, 3 millimeters, and that is the same as the door, which means that it's in line with the door. Yep, that's 3 millimeters. And if this is in line with the door, then that means that where that hole is exactly the same distance from the edge as the other one. And I turned off the body, so I got to come in here to find them, which was a mistake. There we go. So now this hole is the same exact distance from the edge of this ring as it is from the edge of this door, is how this works, because they're both relative to the top edge here. So that solves our problem, because we already know we have enough meat around here. We've already determined that. If we didn't know that, then we'd have to fix that. But we're good. So that is problem number 1 solved. Next thing we want to do is get the mounts installed for mounting the door to the wall to the case and the shaft to the door wall. I keep on going back and calling it a door and a wall. It's door shaped is my problem. That's why I'm doing that. So this is outside wall here. I am okay. I don't actually want to put these mounting holes for the shaft here yet, because I want to mirror everything first. So we're going to go ahead and work on the holes to mount it to the outside case. So let's go ahead and do that. So do I have an inside of, I don't think I do. Nope, absolutely do not. The funny thing is that, oh, there it is. I was going to say, I thought I had an outside construction plane. I just didn't see it. This outside construction plane and this, which I believe is the holes for mounting the shaft. Okay, I didn't actually, it doesn't look like I actually put anything on there. Yeah, I guess we can keep them. I was going to say we can probably delete those, but we'll keep them. Alright, so one of those things, come in here, project out some stuff, draw some stuff. It's occurring to me, I did this overlap, this 2 millimeter overlap here. I made this shorter, you know, in order to have this overlap. Here, from the bottom it's easier to see. So this L-shaped overlap here, that probably wasn't necessary because I was already going to be putting mounting holes around here, which would hold this in place. It does make it more sturdy, but at the end of the day, more sturdy, more solid, less gaps, you know, it does all that stuff, so it is a benefit. At the end of the day, though, maybe not necessary is the only deal here. And actually, I should only need this projection plane right here. And I might want to also include where those holes will be from the handle shaft, just so that I make sure to steer clear of them. I should be able to, but just on the off chance. Yeah, let's just get, nah, I don't want to junk up the sketch too much, so we'll go ahead and do that. And that should be good. And all this is just construction lines. Let's turn off some bodies, drop the bodies, and toss in some holes to mount some stuff, and then we'll toss in some hexes to do some nuts, and then we will make sure that they're far enough away from the wall. Actually, let's see. I may actually, because these are overlapping. Yeah, okay. I think I clicked this at the first time and then I stopped myself and backed up. I do need to know where the inside of this wall is because it does overlap. So that is why we're bringing in that right now. There we go. Drag him out a little bit. And there's going to be enough, because it overlaps by this much, I'm going to assume, so it's 2 millimeters. 2 millimeter walls is enough for us. So we can go ahead and butt these nuts right up against this inner wall, because the door itself will have enough clearance, or enough meat on the edge rather. I said that, but that is not entirely accurate. Because we're extruding these backwards is the only thing. Nah, okay. These are getting put on, that's right. I'm going to put the nuts on the inside, which means that the nuts are going to, and let me just get some dimensions in here. The nuts are going to be in the walls here, in the case walls, which means that they're going to have the entire case wall meet, which means that we're 100% completely good. So we will just get all this stuff dimensioned, 5.45, and we will go ahead. Yes, that could have been tangent to the circle because there was 5.45, but that's okay. It doesn't need to be. Nobody's going to complain. And everything else can just be equal. So that. Draw my other circle in for the head. That. We'll get you like that. Ah, come on. There we go. Equal that. Inside circle, outside circle. And then some collinears, because these guys can be right up against the wall, as we discussed just a moment ago. And I will go ahead, and the top ones don't really matter, but I will go ahead and put some clearance on the bottoms. Actually, you know what? Rather than do my circles like I normally do, I'm just going to use this point. Move him 2 millimeters off the bottom. There we go. Why you no constraint? That doesn't make terribly much sense. What part of you can move? Nothing, right? Huh. I wonder why you are not constrained. Collinear there, all your sizes are equal. That's 3 sizes, 3 equals, and you're from the bottom. Fascinating. Fascinating. Okay. Let's see. 4 up here. I think I'm just going to attach these guys to this point where it starts turning in. And actually that guy, just like the other one, that's really interesting. I wonder why these two opposite corners are not constrained. Let's see. Let's try thinking through it again. So my circles are concentric, so my circles should be constrained. Both my circles have equalities, so those should be equal. So those are constrained. The one edge is equal. The one edge is all we need because they have the polygon trait. This polygon trait makes it so that all sides are equal. As far as I'm aware, I haven't been able to change the sizes. I tried once separately. The collinear here keeps it from moving left and right, so the x-axis is set, and then this stops it from moving north and south, because in order for it to move north and south, this side would have to change sizes, and it cannot. We already established that. The last thing is rotation. Rotation cannot happen because it is constrained in this orientation and that orientation, and we're on a 2D plane, so we don't have to worry about the third orientation. So yeah, I don't know why it's not constrained. TLDR. Okay, remember how I said I wasn't going to do my 2 millimeter wall around the edges? I lied. And suddenly it's constrained. I guess it's just fusion being fusion. The reason I am doing this is because on the back side, on the case side rather, we are going to need to compensate for overhang. So I do actually need, plus these are going to be countersunk into the part that's overhanging. So for that reason, we need some meat around them, because unlike the front side, which is going to be inside the door, this side is going to be free floating in space. So we do actually need that. And actually, I did not need all these though, because as previously discussed, if I just put a circle here and make it equal to the other one, we should be Gucci. And fascinatingly enough, I somehow lost constraints on these two guys, even though the circles are the same exact size. But whatever. Alright, and I think that's everything for the mounting to the door. So let's go ahead and get our door, outside wall, whatever you want to call it. We'll get this implemented now. So let's extrude. We're going to start with the stuff that's going on the door first, because we are currently inside of the door component. Bodies, distance all. So these are the holes, mounting holes. This is the countersinks next. Boink, boink. Boink. There we go. Boink and boink. That's 4 of them. From object there, and -2. Or maybe not -2, maybe just 2. Alright, so there's the countersinks for the bolts to attach. And now we can come back to center shaft, and we can extrude out. I'm going to do this and then deselect the holes in the center, because it's a lot easier than trying to get all these little corners. When you do it like this, when you have everything on the same one, then you got to get each of these little corners here. So you're better off just selecting everything and then deselecting what you don't want. Here's a body. And that plane is good. I don't know whether or not to trust it. So for example, I can hit from object and click that and we'd be fine, you know, but I probably should just leave it to profile plane and not mess with it. So 2 millimeters here. We're going to join, not cut. And let me turn off the outside wall to make sure that we're not screwing anything up. This obviously looks a little bit ugly with these circles not matching the bottom. We could fix that. I just don't see the need to. It's one of those things. It's a rather easy thing to fix too. But again, I do not see the necessity of doing so, so I will not. Actually, you know what? I guess I do see some benefit. Okay, let's fix it. So I'm going to do this. Whoops, I gotta come inside the sketch first. Turn the body off so I can see what I'm actually selecting. I'm trying to turn... Am I not inside the sketch right now? Am I inside some other sketch that I don't know about? Doesn't look like it. Let me minimize this stuff just so that I'm not always looking around. Alright. Why can't I... Oh, is it? I think it is. Okay. I was gonna say, I did that. That screws up my selection a little bit, but I guess it's not that big of a deal. And now you should be a profile. So that looks like that's solid, right? Which suggests... Huh. That should be a closed profile in the corner here. It is saying it's not. So let me instead, now that we're... Yeah, delete you, delete you. Let us tangent that off the bottom then, in that case. Okay, it's saying there's only one sketch line. So that... Huh. Oh, I see what's happening. Okay. Okay. The line I thought was solid was actually the dimension line. That was silly. Okay. Silly. And now that's a profile. So there we go. So that's that corner, and then we just right angle and tangent right here. Tangent, right angle. And that gets us our profiles over in the corner too. In theory. There we go. Okay. Wasn't selecting. And we can come up here and do the same for these guys. Sometimes it gives you that tangent, and sometimes it doesn't. Like a tangent right angle. Yeah, I'll cry about it. Tangent and right angle. Now, the only question is, do I bother doing this direction too? Because this direction is less important. The idea here, the reason I didn't really want to do that, that's why. Because now I gotta, when I do my all select, I get the center part too. Was one of the reasons I was avoiding doing this, but point being is, let's see. Yeah, it's one of these things. This line doesn't have a natural place to be, is my only issue. Like, you can't actually right angle necessarily off of this. So what you could do is you could determine a tangent right and then right angle off the tangent if you had a place where you felt it was appropriate. But as you can see, this right here, I mean, it's going to be, I can do this. Even then it's not constrained, which makes sense because this can stretch like this. So it's one of these things. You see how Fusion even complains when I try to put the other one on there. There's not a natural place for this line to go, point being. So I think I am going to leave those lines off. We'll just use the rest of these though. Unless I wanted to go way up high, but I don't think I do. So let us come back to what we were working on. And I haven't actually extruded it yet, right? Yep, okay, cool. So let me grab like this, and it does look like I managed to dodge the full frame, which is good. That is E. I was looking for 2. 2 is slightly smaller than E. 2 is slightly larger than E, rather. E is 1.87. What is E? 1.85? 875? Hold on. I got this in my mind. Now I want to. Now I want to check it. Wait, is, for some reason I thought, is E used sometimes for the golden ratio? For some reason I had it in my mind that E was golden ratio, but it looks like my brain is not correct. Mathematical constant E. E, mathematical constant. Oh, Euler's number. That's right. Derp. Yeah, 1 over 1, 2, a product. Okay, yeah. Okay. Whoops. So it is, 2 is slightly less than E. I'm a derp head. Okay. This is why I don't do math on stream, right? Okay. So we're joining here. Join. And I forgot to get rid of the center holes. No problem. We can fix that. We have the technology. Okay. Alright, so that's that. And now we want to extrude out the hexes. Bodies. And we do need to come back in here and snag these corners, which is a little fiddly, but not that big of a deal. Bodies. Wrong bodies. Those bodies. 2. And join. Oh, from object, of course, we are not progressing. From object, there we go. And now, to loft out. Actually, you know what? I should do this the other way. So, you know what? It's fine. We'll leave this as is. There's a couple different ways you can do this. So I used to. go ahead and put slots in here. So this would be enclosed with the ramp down that we're about to do, the loft down, to provide relief for the overhangs. And then I put a slot in here for the nut to go, and the nut would slot in. So I would actually, in those cases, turn this so that the flat edges were accessible, because you want to slot the nut in. So in this situation, with the nut oriented like this, I'd probably use these two edges if I needed to. But otherwise, if I wanted to keep this flat right here, I would probably use these two edges and then slot the nut in from this angle here. Control Z, I don't want to move that stuff. So I would slot the nut in along these two edges, just slide it in, put a slot in here for it to go in. I have found over time that those styles of captured nut tends to strip out, which is the biggest problem. And therefore I stopped doing that. Because if it strips out in there, there is no way you're getting the nut back, and probably the screw, the bolt. The bolt probably also gets jammed up inside of the nut when that happens, which is the reason why it stripped out in the first place, at which point there's literally no way you can get it off. So what I've been doing more recently is I'll loft down and I'll just cut out the nut all the way down to the bottom of the loft, and then just insert the nut from the bottom. And that way, if the nut gets stuck on there, you can knock the, you can hopefully, and it's one of those things, it depends how far the loft goes down, but generally speaking, it doesn't go down far enough relative to the length of the bolt. But generally speaking, you'll be able to knock the bolt all the way through with the nut stuck on it, and then get to it with a pair of pliers and try to get it off at that point. Sometimes you just got to scrap it, but you know, if you can at the very least. Oh, and the other thing, even if you can't get to the nut at the very bottom, you can still cut the top of the bolt with a Dremel and then knock it back out, knock the rest of it back through, because you have the clearance out the bottom. So that's why I changed how I've been doing these. Just a brief background on that. So I do not need this sketch anymore. One of these things where it's better for me, so I'm going to do it like this really quick just to get my number, just so that, you know, I don't have to do the math myself. But it is better for me to use a plane going parallel to this and then loft down to it like that, then do it this way. So sometimes I'll do this, right? I'll draw this triangle in here, set it to 45, and that is my loft, or my extrusion, or whatever, however I'm doing the overhang relief. In this situation with the lofting, it's just plain easier for me to sit here and go, okay, this is about 8 millimeters. I'll round up to 8 millimeters. That way it's even less of a slope. The slope is even more steep, I should say. And then Control Z. We'll go down here 8 millimeters. And what this will let me do is it will let me just have a point for all four at the same time, is what it's doing. Did I hit cancel is the good question, because I don't see it. Bodies. Intersect. Oh. I was not on bodies. There we go. Now we're intersecting the body. Make that construction, and like I said, now I can go ahead and actually I do want to project though, so that I can keep it in line. These guys. It's one of those things, it's kind of up to you which point you grab, because it's irrelevant, I should say. I guess I'll just grab the circles to reference off of the holes, rather, because they're easier to distinguish than rather random lines. And do that. Just bringing this straight over to the wall, because all I need is this point to loft down to. Now, if I wanted to, I could grab the other way to do this. So I'm going to a single point here. I'm going to a single point loft is what I'm doing, and going up, so it's going to be conical. You could also take this whole entire profile, reference off of it, and then loft up in a ramp, in a straight ramp. That's the other option, but I will go conical here. Conical, however you would like to pronounce that. Turn construction lines off, hit the finish button, and now we will loft. Create loft. And one of these things, sometimes loft lets you do stuff like this, and other times it doesn't. So yeah, yep. One of these things, unfortunately, this I believe is just going to end up because I don't. Well, all right. If I wanted to grab a mid-plane, I could. I could arbitrarily grab a mid-plane between these and then set up the mid-planes. So if I make a mid-plane down the center, a mid-plane through the center this way, so X, Z, and Y mid-plane, then that's two things on the. That's two pieces on the timeline, plus my loft, plus two more mirrors. So that's 5 things on the timeline, or I can just loft 4 times. So one of those things. I'm just going to loft 4 times instead of trying to mirror everything around. Now, that being said, those mirrors could also handle my cuts. So if I was doing something weird with the cuts that was not symmetrical, that would be a situation in which I might be able to save timelines, but because all my cuts can happen all at the same time in this situation, that is mirror. I was talking about mirror, and I ended it with mirror instead of loft. There we go. Because all my cuts can happen at the same time at this point, I don't need to mirror the cuts. I can just do them all in one, so I won't be saving the timeline entry in that situation. Alright, there is that. Now, one other thing I should address here is, admittedly, the let me actually come back here before I do this and set up a just to make my life easier, a section analysis. One thing I should admit is that alright, fine. I understand why you have a problem. We're just going to come back over here. One thing that I should admit is that my loft is not perfect at this point when I cut through this, because this is around the z-axis, 180. Nope, wrong. 0. There we go. This is not going to be perfect because where the loft starts is a bit lower than the, or a bit higher than the point. So you'll see in just a moment, as soon as I get this cut, that bodies, whoops, not bodies, section analysis. There we go. And actually, that is a good reason why I probably should have used the profile of the sketch instead. But point being is that you see how this right here was my point where I started, and this is where the loft actually is starting now because I cut that out with the hex. So that is why I did it at 45 instead of 60, because I knew that it was going to go up higher. So my assumption here is that this angle from here to here, and it's actually looking... The funny thing is I've never had problems with this before, doing it this way, but it is looking a little funky at this point, I gotta admit. I wonder if I did this a bit differently than I normally do. I might have. So anyway, the point being is that the angle there is not going to, I don't imagine, be a big problem, which is why I'm not terribly concerned about it. And I actually can't drag because I'll get this. Oh no, I can drag. Yeah. Okay. Let's do that. I'm going to hold down the control key and then select. And that did not work. So, wrong button. Yeah, alright, fine. Huh. Please, thank you. I think that's everything. Looks good. Looks good. Looks good. Okay, and now here we're going to do from object using that section analysis that I had. And just in case, because I got distracted and not sure I finished my cost, but no, I definitely did. Yeah. So the loft now I believe is closer to 60. I could check it, but I do not see the need to. And therefore we're fine. Just to repeat myself, because I am jumping around a little bit here. So there is that. And again, I haven't had these fail before doing it this way. I don't think I've done anything different than normal. I just don't recall ever seeing this overhang at this point right here. Is the only thing that concerns me a little bit, but it's probably going to be fine. So that is that. And these are inside the outside wall. So we don't want those yet because they're the holes, which means that I believe we can just mirror everything now. So let's go ahead and do that. Features, components. Not components, features. So I want, let's see, not this guy. I want, do I need this guy too? No, I don't think I do. Let me back up here just to make sure that okay, that's the round guy, so I don't want that guy. I don't need this guy. Technically speaking, I can use that guy. No, I shouldn't use that guy. So I'll skip that guy too. And then the rest of this I believe is good. Okay. One of those things, the other thing that I could be doing right now is just mirroring this in pieces, which would be a bit more responsible. So, but, don't think it's necessary, so we're not going to worry about it. The other thing I should have done before I spent all that time selecting is actually to find a midplane. That would have been good. Professionals. Construct midplane. And this is the X midplane. Alright, take 3. Create mirror. That guy. Not that guy. Yeah, that guy. Yes, that guy. That guy. Not that guy. This guy, though. I do need that guy. That guy, that guy, that guy. And the rest of these guys. Q. Oh, this all is going to be a problem. That all is going to be a problem. Okay, I'm going to hit this anyway. And then I'm going to fix it afterwards. Because that all... Okay, that all did not... Okay, there it goes. Yes, it did. You see how it blew out the other end? So, instead, this is going to change from all to object. And I will use the midplane. There we go. And let's turn on outside wall number 2. Okay. It created another body because I did the component. Okay. You know what? This is fine. This is fine. It did not, however, cut. It did not combine correctly here. So let's just take a quick run down the different options we have here to see. Okay, that one did do that correctly. Now let's check that everything else looks good. Everything else does not at all look good. Okay. So we will not be going for optimize this time. Adjust. Adjust is what we started out with. Identical does not work. So we will go back to adjust because that's the default. And we will just go ahead and put the combine in here ourselves. Boink, boink, cut, keep tools, good. Alright. And at this point I will add my relief, which I believe is going on the case instead of the outside walls. So I'm going to go ahead and back to 3D printing relief just to make sure that we don't, run into a situation with, and actually one of those things, I have the lofts, obviously, for printing upside down, so printing like this, but the bottom part here obviously has this, and this is, again, I will go ahead and put supports in here. I don't see a way really to get around that unless I made this wall solid and only made one removable wall, but I want both walls removable, so we will go ahead and put supports on the one side. So there's my 3D printing offset for practicality purposes. And now I should also, yeah, all right, fine. So I've been debating because recently some of my hexes have been showing coming out actually on the loose side instead of the tight side. So I've been debating not putting this offset on hex nuts anymore. One of these things I will for now, unless it becomes a serious problem, just because it's better than not being able to get the nut in there. So there's that wall. Oh dear goodness, new offset. I want, oh, that is why this one is, this side is the hard one to grab, and now we can come back inside and grab the other ones. Until it becomes a serious problem, I will continue to put these offsets on the hex nuts. Minus 0.05. Okay. Which one is the problem? What face am I deleting? I'm not deleting any faces. It's just dragging out to the corners. Oh, okay. It's this seam right here. It's having a problem with this seam right here, I believe. Let's see. Does it accept it now? Yep, it accepted it now. So it just had some problem because this seam right here in the round part, it would have to offset that while it's moving this up. So this goes outwards from the center, right? And then all of a sudden it has this seam right here that it doesn't know what to do with because it's, part of this. So that presumably, and that is the reason why I didn't bother offsetting the interfaces too, because obviously that's all connected. One of those things, again, it's not something I was considering doing to begin with, so we're not going to worry about it. One fewer faces is one less chance that the nut ends up loose. I am kind of curious though, maybe not that way. Maybe check this side. I am curious to make sure. So this 555, and we'll check if this is a timer over on this side too. All right, that's a 550. I was curious about that one. The mirroring, whether or not it would. Oh, that's the top and bottom. I'm comparing apples and oranges. That's right. So this should be 550 back here. Not a timer. There we go. Okay, cool. I just want to make sure because it's mirroring with adjust. I just want to make sure that it did it correctly. Just one of my little bits of paranoia. Alright, and now we can go ahead and mount the outside wall to the handle shaft. So we come here, pick up these holes, project these holes, and actually I want to project from the other side. Let's turn off the bodies and the bodies and project from that side because that side has the actual 3mm on them. And on this side we're going to end up with the hex nuts. Is that the right hole? That is not the right hole. Okay. Let me do this and then do that. I was going to say it didn't look right, but At the same time, I don't assume that I'm always correct, so I had to double check. Whoops, Control Z, that was bad. And 5.45 as always. And again, I will just do, I've switched over to doing it this way instead of copying over the dimensions, just because, again, the polygon shape makes sure that all the walls are equal, so, you know, going side to side is the same thing as defining a single side. So, for example, I could, from now on, do 3.147 and just define a side as 3.147. I don't think that's fairly accurate, so it's better for me to use the 5.45 across the center line here, which is why I continue to do it this way, but the equal sign still works. So, whoops, Control Z. There's that, and then you guys get your captures as well. And that is a construction line, and that is off by 2. And as you can see, we're off on a little bit on the edges here. I'm going to go ahead and turn these solid again to make sure that we don't cut them. But that's not that big of a deal. I will, however... no, I will not. I take it back. Ignore what I was about to say. Otherwise, I guess we just call these horizontal vertical because I don't have an obvious orientation for all these guys. And again, you can see Fusion has decided at this point that this guy is not constrained on these 5 sides, even though it's a polygon. Whichever, Fusion, whichever. There's that. And now we can extrude. Extrude. Bodies. Turn the bodies back on. From object. And -2. There we go. And then we can go ahead and extrude the holes out. There's that. Distance all. Flipperoni. And make sure the other wall is turned off so that we do not cut it. And it looks like I missed a hole. Nice. And somehow, wow, okay. Sure, I missed this too, I guess. Okay. Cool. Offset. Do. In theory, you should be able to get this in just 2 views. Like this. Just for record, I was taking 3 views to do it. Being inefficient. Name of the game around here. All right. And now that is the front and back attached and the handle attached. So now we just have the micro switch, getting the micro switch in position, and the peg. I forgot that one. That should have been on our list of things to get done. So let us hop. Oh, we are all the way back up. So I can do this. And what is that? Okay, that's my peg. Cool. Now the weird thing is that I believe was supposed to position that up against. Where is handle? Oh no, I guess that. Huh. When did you get? Oh, that's right. The shaft moved when I moved the when I did the alignment. Okay. Let's actually Control Z. Before we do this, let us go ahead and as built joint this and this as rigid, and as built joint rigid that and that. Or actually, yeah, good point, Fusion. Good point, my misclick. We can just do a rigid group here. And again, as per our usual arrangements, I do not particularly like includes children in the rigid groups, so I deselected and selected everything manually. And now that those are rigid, this should pull the handle over. That did not pull the handle over. Excellent. That appears to have done nothing. Yep, that appears to have done nothing. Good. Align, handle. We've done this before. You should be familiar with this. Inside wall there. Okay. Finish position. And for good measure, since we're doing joints right now, this on that, and this is a revolve around that. Okay, there we go. That's a revolve, and now we can go ahead and put our peg in, which is still on the timeline, so there is that. Now, looking at this, fortunately I do still clear this guy, it looks like. We start out at, again, this would be a 90 right here. This angle would be a 90. In theory. Yeah, I believe in theory that's, it might be slightly more than 90. Anyway, point being is we're only going to move 30, let's say. So, if we double check on what we're going here, we can go ahead and change this to object instead now. Now we know what we're doing. From object. Okay, from object looks like it should be correct. No, it doesn't look like it should be correct. This should be from object here. Evidently that was one of my very sillies. And actually I do want that guy. I just want to turn the other wall off. There we go. To that. And now plus 12. And that does appear, because it's so big, to be scraping the inside of the roof. So we will go ahead and make him a little bit smaller. Again, he was much larger. Okay, we did take him down from 10. Originally he was 10. It looks like we took him down to 6. Take him down to 4. That's fine. And now he is not scraping the roof, which is good. And furthermore, he is scraping this guy though. So we'll go ahead and adjust that too. And that is something we can just project in here to make sure we avoid. I don't think we actually need this outside hole at the moment. If I recall why we need that, I will put it in. Actually, I will put one back, and I'm just going to use this so that we're not right up against that other circle right there. We'll give ourselves a millimeter of spacing and then tangent off of that other circle. Again, just as a means to make sure that we're not binding up on it. Alright, there is that. Next thing we want to do is go ahead and cut our slots. Again, the slot for the mounting plate can be however big we want it to be, and then the slot for the inside here should probably just be a slightly larger than the peg. So that is the situation now. The question is, what plane seems most correct, which I guess I just do it in 2 drawings, I guess. Yeah, I guess I'll do it in 2 drawings. That would be most correct, most proper, instead of using 1 drawing for 2 different components. Face of mounting plate. Okay, we don't have back of mounting plate just yet, so let's go ahead and get that in here. This plane does technically, in this orientation, align with other planes. However, it may not at some point for some reason or other, which I cannot define, but back of mounting flange. Actually, I have literally no reason to use that plane, so let's not. Alright, we're going to project that out, and again, we are going to just chop out literally everything, because it's easier. So, I'll do this, make some construction lines, turn some stuff off so that we can see what we're working on. Body, and now we can go ahead and make sure that is pointing towards the middle. Did that work? Yeah, it did work. Good. Okay. And that can be... Let's see. Well, that's a hole right there, so I probably want to move this at least 2 millimeters off the hole, which is probably that distance right there. Let's check. Yeah, that's 2 millimeters. Yep. So we'll make that tangent to there. And this is the start of our cut, and then again we want so I keep on saying 15 should be good enough. It's one of these things I'm gonna have to see how we're going to be able to adjust, because I don't actually know the swing of how much turn it gets based on the micro switch positioning. I'm not sure how we're going to be positioning the micro switch to make that work. I'm going to put it at 30 right now. We may want to change that, but what's the distance here? 5.8 is 6.8 is what that says. 6.8. That is okay. That's close enough. I was curious whether or not I wanted to move this down to be closer to here, but I think that's probably close enough. You know what? Again, this is just clearance. This is all just clearance on this mounting flange, which means that we can go ahead and just do this. Just do 40 degrees, and we should be good. And then I'll turn these guys back on to give me a profile to extrude and clear that out. I guess it can be all. Cool. One down, one to go. Center shaft. Turn you on, and actually we are not on the center shaft, we are on the outside wall is actually where we're putting this. And same deal. That can go there. This is inside out wall. Inside wall. We can do this on the outside wall. That's fine. Project out. That handle. That guy. And the rest of this, I guess, just to be safe. Turn stuff back off. Body, body, body. Alright, and here again, what I'm going to do for this one... Oh, excuse me, pardon me. This is not the correct center line for this, so I actually want to project out the handle shaft is what I actually want to project out here. I want to project out that because that is the center of our rotation. Did I not just turn that back off? I guess I didn't. Okay. So... Okay, yeah, there we go. That's the center line I was looking for, the center point I was looking for. I'm going to do this. Set up these construction lines here for 30 degrees. And use those to reference off of. And then toss this in here. So we'll give ourselves... 1 millimeter is a little... it's a bit much. So it's one of those things. The peg is not riding on the slot, but which means that it doesn't matter how big it is necessarily speaking, but it can spin back until it hits something, and that something being this guy right here. So we probably don't want to use the full millimeter. I want to give it extra clearance just because I want to make sure it doesn't snag, but at the same time we don't want to give it so much so that it swings back too far, the peg. So that is that. And actually, you know what? I should do this the other way. I will do this the other way. And let's make a curved slot, because this is a slot. So center point slot, boink, boink. That is funny. That does not look like that's actually on my... Huh. Why don't you want to... Why aren't you... That's funny. Why did it not snap to... What is going on here? Why don't you want to snap to... Okay, delete you. Actually, I'm going to control Z out, because something is going on here. There's that. I'm going to make this equal to that. And that needs to be on this guy. Your job was to be on that guy. Okay. This should work now. Slot, center slot, boink, boink, boink. There we go. Much better. Except for the fact that I ended up with construction lines instead, but we can fix that. 0.5. There we go. And you are no longer construction lines. Alright, so that's our full 30-degree turn right there. Again, we could technically make it wider. I say again, but I don't know that I necessarily voiced that. I kind of alluded to it, but back to the placement of the micro switch should determine where, how much of the degree turn we get. So we could make it longer than 30. Okay, yeah, okay. Okay. I do know how we are going to do this. Yeah, okay. Let's grab the micro switch. And we'll want to align the micro switch first. And back to that mounting plate. This is why we have the mounting plate, to make our lives easier. Modify. Align that to that. And that is not quite correct. This side, please. Huh. That to that. There we go. Much better. Oh, shoot. I said this before. And I totally forgot. Because we want these pins facing downwards, I totally forgot we had to flip this around. Derp. Okay, capture this. We will go back and fix our mistakes. That starts with this guy right here. So this guy was supposed to be on the other side. So we untangent this here, and that allows us to drag it to the other side. And oh boy, no, this is fine. Yeah, this is fine. I was a little concerned because this is now the end point, because we're still rotating down this way. We're still rotating forwards, right? Because we're still rotating forwards. This is now the end point because we're going clockwise. But that's fine. It doesn't necessarily matter that that's the end point, because our slots, we just readjust for that. So this guy, this is our cutout slot, which evidently did not use anything, I guess, which is a little weird. It's just tangent to that. I did not actually reference the hole, I guess. Fine. Tangent to that, okay. And we do have to fix that. Oh, wait. That's funny. Oh, the circle gets interrupted down here. That's why I was going to say, this circle should be a complete circle all the way around. A complete solid circle. So it shouldn't necessarily matter. Yeah, there we go. It gets interrupted because of the hole. And now this guy. This guy does reference the other guy. So our issue at the moment is... Can I do this? Nope, not going to be able to do that. So, Control Z. Pardon me. We want to unclick that. And now can I drag you over? Nope. Control Z. Let's see. You know what? It's easier just to start over at this point. Basically, that tangent is to these lines. We've already disconnected ourselves here, right? Yep. So, I'm looking for that guy, I guess. Yeah, see, I clicked that guy, but his coincidence constraints are not showing up. Which makes it a little difficult to fix. So I'm going to just go ahead and delete all this. Delete that. And swing you over here. We'll do our 30 over this way. 30. And redo our arc. And that's the way we'll fix this. Oh, I said arc, which is why I'm getting confused here. There we go. Slot arc, boink, boink, and boink. And then we can drag you out and go, not like that though. Control Y. I wish Control Shift Z worked. Huh. Oh, you did not actually coincidence with that guy again. That is why. 0.5. There we go. And let's check you out. Missing profiles. That's fine. Question mark. Body's in the way, I guess. There we go. And now back to this guy. Okay. Where's my micro switch? There it is. There's my micro switch. There's my bodies. So this micro switch needs to be pivoted, I believe, is the deal here. Let's see. So the point of having this mounting plate is so that I can on the sketches get it, but I actually have to get it into position manually. I think at this point it might be easier for me just to go ahead and grab my sketches and just copy the numbers over. Yeah, I can do that. Okay. This is how I'll do it. Back into outside wall. Please. Oh. Control Z. There we go. Control Z. Control Z. Control Z. There we go. Turn you back on. I actually don't really need the bodies here. I guess I do. Okay. Just to get my, inside wall is fine. Just to get my projections. So there's that. We'll do that. And then what I'm going to do, I'm thinking, is turn this off really quick. Turn this all off really quick. Just so that I have this sketch here. And I'm going to project. Okay. Just my eyeballs. Good. They're there, and that is the tail right there. So I'll grab those two right there. And project those lines over. And then use those to reference off of. Is the idea here. And turn you back off. So now I can equal sign this kind of stuff. So here is my, whoops, that is not a, let's construction line. And this is my corner for the tail. So I want to replicate that right here, I guess. So we'll make that guy equal to that guy. Toss this guy in here like this. Actually, no. How do I want to distinguish here? And the funny thing is that it looks like I actually don't have the space annoyingly enough. Looking at it. I guess it doesn't necessarily need to be on a perfect angle, huh? Yeah, I guess it doesn't necessarily need to be on a perfect angle. It can be up like this too. That works. Okay. So back to my issue. How do I want to reference this? I guess maybe I want to reference that instead. Maybe do this. There we go. Just trying. I'm getting creative here. Let's be honest. This is rather abstract way to define points, but in theory it should work. So this is this, this is this, this is this, and this is this. And in theory it does not work. Control Z. So what if I draw an extra my idea here is for any amount of geometry, provided they are equal, they should reproduce the geometry, is my idea here. Interestingly enough, that does not appear to be happening. Alright, take two. Again, this would be easier if I had an easier way of lining up the... you know what? I said it'd be easier if I had an easier way of lining up this micro switch, and the fact of the matter is that I guess eyeballing it is a bit easier and faster than doing what I'm doing right now. Finish sketch. Alright. Let's hop back up in here. And we will go ahead and eyeball this into place then, in that case. So let us go ahead and click that, rotate it. Its rotation point really does not matter at this point because we're just eyeballing it into place, unfortunately. I guess right there for right now. Okay, actually I should just use the translation, honestly, is what I should be doing. This guy over here, I normally don't use this guy, but we're doing everything all at once, so it makes more sense. That way, that way, that way. There. I don't particularly like doing it this way, but beggars can't be choosers, frankly. It looks like because of this hole down here, we can't really get close enough. This ridge right here. Maybe if I go this way, maybe if I put a little bit more angle on it. Yeah, okay, fine. So there is our lowest point, and then I just rotate back and see these prongs are now over here overlapping this, which is a problem. Okay, so we need to rotate back a little bit more. Actually. It occurs to me, as long as I can get it close enough, I'm just thinking that the bolt this is going to be over top the nuts anyway. So you see how that sticks out over top the nuts? I can always have it stand off and the bolt doesn't come all the way through to run into it. So it's not actually that big of a deal. Which also means that let's see. This is a little bit tricky. The other problem is that I'm thinking, you know what? Since it clears everything, it's probably not that big of a deal. I'm probably overthinking this right now. That's what I'm thinking. So long as this rotates, so we probably actually want to bring this up even more then. We just want this rotation to be more or less centered here. One of those things, I'm never actually going to have it that close, I don't think, that little of a swing. So this basically is alright. And then again, we'll just put some standoffs on here and make sure that this is far enough out that we can get to it. Just, oh no, hotkeys. Okay, capture position, good. Okay, I was very concerned right there that it was Control Z all my stuff. Alright, cool, let's capture position. Actually, I need to back it up to its starting position. Let's start it there. I'm going to go ahead and start it. Shoot. So here at this point, let me look at the body. Yeah, here you see our wires are running into the wall here. So that's not really going to work. And actually our micro switch is running into the top there, which is also a problem. I did not notice. So we need a higher roof at this point. That's fine, that's fixable. We can fix that. We need a higher roof. But this over here, this side, that is more of a problem. Which means that we need to angle this more. So this needs to be minimum angle like that. So this is at the bottom right here, which again is fine. We can stand off up there. My biggest issue at this point is that right there. The fact that if we try to adjust this, we won't reach. Now, one of those things, practicality speaking, this is probably, let me zoom in a little bit so I can get a smaller movement here. Alright, that fits, and practically speaking, we're never going to adjust more than maybe right here. So, you know, at this point, so this is the 15-degree point, more or less right here. Actually, that's literally what it says on my rotator. So this is the 15-degree point, which means that that is a very small amount of turn on the handle to actuate this. So chances are that we're probably fine here. -5. 5. Yeah, we're probably fine here. Maybe up a little bit as a starting point. -3. -2. There we go. All right. Let's call that good. And again, we will, at this point, because I moved that down, this rotation here should not hit the roof. So we don't have to readjust the roof here. And this is a little sketchy right here, the amount of space that we have to put the wires in. But I'll make it work. It's one of those things. Which one of these is the top one or the bottom one that normally open? Let's see if I'm in this orientation right here. The bottom one is normally open, which is good. That's what we want. We want the bottom, so the one with more space is the one we want to be connected to because we don't want the button triggering until it's actually pressed. So this is fine here. Okay, we've done it. We got over that issue. All right, and it looks like I lost the... let's see here. Back to this, whether or not I want or need to fix this. I think I do need to fix it. So, tangent plane, and hopefully nothing breaks. There we go. We'll just go up to 5 and see if anything breaks. Something broke. It doesn't look like anything on this broke, but it does look like... Oh, no, okay. That's just the mounting plate sticking out the edge. I saw the mounting plate sticking off the edge, thought that something was broken. It does not appear to be the case. That all appears to still line up. Good, good, good. That is our pin coming through, and some reason the pin is not connected to the body, which is excellent, excellent. The pin does stick out far enough, in fact too far, so I will come back in here and adjust this. Wherever it is. Now, unfortunately, we can't adjust it to where... Actually, maybe I don't adjust it, because again, we're going to put this on stand-up, so I might have to actually adjust it further out. Okay, blue, light blue, light blue, light blue. Light blue does not actually line up with our toolbar, so let me hop in here to handle. And that is going to be a join. That's going to be a join, Josephs. Alright, there we go. Yeah, so I'll leave it at, as I was saying, at that distance, because we may have to actually extend it out to hit the micro switch to begin with, once we get the micro switch up onto stilts. So, back to where we were. Back to the beginning. Inside is good. Sketch, thank you all. Project out. This stuff is what we are looking for. The mounting plate. Turn that back off. And turn these to that. I'll go ahead and toss the standoffs here. Let's see what 3mm look like. 3mm looks like it might overlap, so I'll cut it back a little bit. The size of it is not actually, I'm not really particular about the size of it. And then the next thing we got to do is back to the pivot here. Now the pivot was actually center of the body is how I was pivoting it. If I pivot off this corner, then what is probably going to happen is it's probably the flange, the trigger, whatever the heck I want to call that, is probably going to run into the roof if I pivot. Actually, maybe not. Let's see what that looks like. One of those things. We're being lackadaisical at this point, so let us go ahead and look at it. So we are pivoting around this guy. Oh, that actually does not hit the roof. Alright, cool. So we can just draw the one slot in that case. There we are. Okay. So we'll again put a center slot arc in. Boink, boink, and we want 30 degrees is what we want. And this is just going to be tangent to that. And I think what I'm going to do is I'm going to go ahead and use the offset here for my 2.5. Flip. Okay, there we go. 2.5. Now that does... Alright, so here's the deal. The fat part does run into our mount here, but we don't necessarily need... it's a bit sketchy. Let's see. And why are you ill-defined? No, you're supposed to be 30 degrees, dude. Okay. Way to be obnoxious. Alright, y'all saw me set it as 30 degrees. Alright. That in theory is 30 degrees. Now, this is going to ask me to set a radius, but I don't want to set a radius. I want to set... Yeah, that's... Yeah. That's what I thought. Thank you. Alright, we are going to do this to solve my problem because things are silly. There we go. Now it doesn't let me drag that, so we are good. Now, back to the more important problem. I guess at this point we just project and cut around is what it's going to come down to. Because I can't think of another better solution, unfortunately. So I'm going to toss that in there and we will just extrude around that. And the marker switch is going to be larger than this pad that I'm putting down right here, which suggests that the marker switch actually needs to get past this, probably. Let's see if I can't pick out a point here to go to. Nah, it's not really giving me a point. I can, however, use the construction line. That guy? Yeah, that guy. Okay, actually, I don't want to do this necessarily, but it does tell me that that's 12 millimeters is what it would be. So I will back this up to 8 millimeters. And we'll spot it. We'll take a look at it with the micro switch on those mounting holes and see whether or not the micro switch is going to clear in the model. So turn off the mounting plate. Come back up here. Oh shoot! That didn't actually join, did it? Join and turn the body back on. There we go. Better. Alright, so modify align, turn the body off, bodies, align that guy with that guy. Just gonna turn it off really quick. Okay. Oh, not that guy, not that guy. Wrong guy. With that guy. There we go. And I know that's doing that right now. That's fine. We're going to go ahead and put a hinge on it, and then we'll align it after we put a hinge on it. That and that. Revolve around that. Oogie doogies. And now we can go ahead and align the other one. Modify, align that guy to that guy. Attempt to align it to that guy. At any rate, hopefully it didn't just explode. It did not explode. Good news. Okay. And we'll capture position here, and then we will set the edit joint limits. Minimum, maximum. Let's see. Okay, yeah. So because the joint was made back there, I'm gonna have to eyeball this in. And then this would be 68 plus 30, right? In theory. So 98 minus, or not. Okay. 68 and 38 is probably more correct. It is. Okay. And now let's drive that just to make sure. Yeah, so that's the full 30. Again, technically, we're never ever going to use the full 30 here, which is why it probably would have been okay for me to stop before we hit this guy right here. And this guy right here is probably just going to cause us problems. In the meantime, it's pretty clear to me. I mean, I'll run it back, but yeah. We actually do not get anywhere near it because we are just on the corner right there. So we could drop ourselves down a little bit closer to the metal. Let's do that. So let's go 6. This alignment right here needs to be fixed now, unfortunately. Again, so this is one of those things I don't quite understand. And it's, yeah, well, I don't understand it at any rate. Is that this, the alignment stuff is a series of commands, right? Between faces and edges and whatnot. And therefore, it should be able to have a history that can be played back. Is the thing that I don't quite get. Because it has a history that can be played back, I shouldn't have to go back in there and readjust that. It should automatically say, okay, this alignment history item had me aligning between these two faces or these two edges in that situation. And therefore, in theory, it should be able to just play that back and run that command again. And if it breaks, then it tells me, you know? But for some reason in Fusion, it doesn't. Don't really understand. But, as usual, I don't know everything, so maybe there's a good reason why it doesn't. I just, I don't get it. And, yep, it does look like we're still clearing that. So the last thing I need to do here is do this, not that, these guys right here. I just want to pocket this in a bit. And I may run into a situation, just because that's so close, where... Okay, cool. It's not close enough. I was going to say that wall might actually get destroyed, which is something we ran into before, right? When I was offsetting the hex heads, it was like, oh wait, I'm going to destroy this wall if you do that. So I was just a little concerned that might happen. It might stop me, but that was not the case. So let us... Did you end up in the correct... Yeah, you did end up in the correct area. This is all fine. Yeah, all the positioning and joints and stuff is going to be a global attribute anyway. And it looks like that peg is still long enough, as far as I can tell. So we will go ahead and leave it. The last thing I could do here is I could try to fit a hex into there and feed the hex from the inside of the handle. So let me turn the other stuff off so that we can see what I'm talking about here. So I could put a slot on the inside here, put a capture nut up there, and then thread on a bolt. That way I can change the length of this peg. Plus it's a bolt and therefore not going to shear while I'm revving the engine there. That is definitely a consideration. One of those things where if this shears right here, this is a rather large piece to reprint, which is a little obnoxious. So my only issue is that we have stuff based off of this peg right here. We have slots and whatnot, and it is a what was it again? It does not tell me. Edge, please. Thank you. So it's an M4 in theory, is the diameter I got there. One of these things where in order to replace it at this point, I'd actually have to unextrude it. So add another extrusion in to, well, either extrude or cut and delete. Those are two options. And do everything after the fact. Well, I guess while I'm talking about it, I may as well just check. Again, this ended up down at the bottom half of this circle, so I will have a hard time fitting a nut in here, but we will just take a look and see if it's even a viable idea. So here's this, and honestly it doesn't need to be an M4, it could be an M3, so because I definitely have nuts long enough for this length, rather I should say. So let's just start with an M3 and see what happens, which is 5.45. And I would need it slotted in, which means that this would have to be more positioned like this. So you can see, well, you might not be able to see because I recognize that that thing is in the way. But this point right here, let me go ahead and project out that okie dokies and then turn that back off. You see how the point sticks out here, which means that that is scraping against the handle. I'm positioning it in this direction because I need to slot it in from the inside. So the slots would run like this. This is the hole I would cut out in order to slide the nut in. And because that is the hole I got to cut out to slide the nut in, this is the point of the nut. And that point is obviously going to be digging into the shaft. Now, on the one hand, I could cut the shaft back or something like that. Well, I could cut a slot in the shaft for this nut to slide in. Fact of the matter is that this is becoming a bit of a pain in the butt and becoming overly complicated. So I am going to rest assured that this is never going to shear off, knock on wood, and just print it. Alright, at which point, there's that. We need the other body here, and then these bodies here. And now I think we are ready to attach it to the extrusion. So now the fun part, because one of these things, this is going to have to go, I believe, on 2 different pieces of extrusion, like our joystick. And it will be really interesting at the end here to pull those 2 into into a single file and see what the difference is going to be between these sizes. Actually, rather than that side, let me get it on this side of the extrusion. And then modify, align that to that. Okay. Alright, so this is now above the extrusion. And frankly, given how so we don't have anything with the joystick. I stretched it over 2 pieces of extrusion, but I had a whole bunch of stuff hanging down between the extrusions, which is why I had it ramped up and slanted in and whatnot. This may actually be better off having a flat bottom and overlapping the extrusion by somewhat. Actually, let's see. Let's see what this looks like here. Here's an idea. Alright, we definitely can fit 2 pieces of extrusion underneath there, and if I go even a little bit further, we might still be able to. So here's the idea. Here is the concept. I guess center shaft, I guess, is the one I'm moving. The concept is -4. Drop a plate down on this side and strap it in on that side. And then maybe not even bother putting any T-nuts on the other side, on the extrusion over on the other side. And just letting it sit there. Because, frankly, a pair of T-nuts here probably holds it stiff enough. Yeah, maybe not. Well, alright, here's the deal. We're going forwards with this. Again, this is set up to spin clockwise here. Since this is set up to spin clockwise in this direction, well, that's counterclockwise from that direction, but clockwise in this direction towards the front. That's going down. We're only ever torquing down onto the other piece of extrusion, which means that we're only ever torquing on the T-nuts on this side. So we don't even need to put T-nuts on the other side, because we're never revving backwards. We're never revving away from that side and lifting the whole entire contraption upwards. That's the rationale here. So I think that's what we're going to do. I think that's how we're going to design this. We're going to make an L-shaped bracket and just plop it down on it. Now that will entail putting some more mounting points on the bottom here. And actually I should lift this up a little bit more. And again, just grab that and lift myself up by 4, just as the mount thickness. And the mounting points, I think I'm only going to, do I only want to do 2? I guess we'll figure that out when we get there. I feel okay with figuring that out when we get there. And this is positioned exactly where we want it, I believe, in which case I might just draw from here. Yeah, I might just draw from here. Okay, so where is outside wall? Actually, let me use outside left wall instead, just because that's the more appropriate one, because that's the outermost shell. We're going to go ahead and grab this stuff and grab this front profile. Okie dokies. And this stuff does not need to be anything. This stuff might need to be something, but I'm going to make it constructions for right now. Let's draw our L in. L, 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 L. We take all the L's. Constraints to make it an L. And this one should be invalid. It is invalid. Good. The universe is in fact Euclidean. Controversial statement, I know. 4, 4 is what we said. This is going to be here and here. And yeah, actually, it is fine that I did these guys down here as construction, because we actually definitely don't need them. And this will be from here. I want this maybe 3 millimeters. And then this guy can just be like that, collinear with that. The idea, again, since we're not clamping down the other extrusion on this side, this extrusion will be bolted to the rest of the frame to keep it from moving. So this extrusion will be held in place and rigid. The extrusion that I don't have visualized here, which will give this a platform to sit on that side that it does not move. So that is that. So distance to object there. New component. Okay. And again, I did new component afterwards, which I've already discussed is somewhat of a mistake. It's cool. It's cool. It's one of those things. I'm being consistent within the design is my justification. Mounting plate. Cool. And now let me go ahead and really quick, right quick, we'll hop into, oh, that's right, I can't edit in place. Oh no, I can hop into it. But I can't hop inside whichever's. Distance to object. Okay. Just for the, oh, but I can't join, can I? Join? Yeah, I can't join. Yeah, I don't know. I don't know what to tell you. I can't join when I'm in there, but I can join when I'm out. I don't know. Don't know how to explain that one to you. Mounting face. This is very straightforward. Just put our holes in here. I think you've seen me do this many times. Actually, you know what? A lot of times I do this off stream, don't I? But anyway, it's very straightforward. It's just we're going to pick up the center line and then put the bolts into it. Mounting face. Bolt holes even. No, don't even have to do anything special, just bolt holes. So grab that. We don't even... well, I need these two edges is what I need. The left and right edges. Otherwise, there's a center line of the Z extrusion. Grab my center line in there to put the bolts on. There we go. Those are construction lines. This is an M4. This is an M4. I feel plenty comfortable with just two of them. If it turns out that I'm utterly wrong, then we will change it, but I believe that is just fine. This 10 millimeters from the edge is arbitrary. Please, thank you. And extrude distance all. Flippity floppity. Only cut the mounting plate. And there is that. So now we just need mounting holes on the bottom. And again, I'm not entirely sure. I was mentioning this kind of mumbling to myself, but I'm not entirely sure how many I feel comfortable with. I guess I'll just do 4 because just 4 because I guess. That is bottom of mounting Oh, I guess I should yeah, there are 2 different mounting faces. There's one for the extrusion and one for the what do you call it? Throttle mounting. Throttle mounting. Extrusion mounting outside. Extrusion mounting face. Bottom of throttle mounting face. Cool. Project this out. Actually, don't project that out. I want to project out the... Let's turn off the extrusion while I'm at it. Extrusion, there we go. I want to project out these guys. This is what I want to project out, so I can keep away from them. Turn that back on. Turn all this stuff off for the time being. Toss these in here. How do I want to do this? Yeah, I guess I'll do it this way. Okay. Feels a little bit silly, but it's a way of doing it. Again, sometimes we try silly things. You on there, please. You on there, please. And you should automatically be on there because everything else is there. And then I will do from the edge. I think this is the closer edge. I believe this is a closer edge because this is a rectangle. So that edge is naturally going to be further away, 6 millimeters. And now for our mounts. Boink, 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 boink. Boink. And this is the 3rd time we've done this before, so you should be, well, the 3rd time this stream we've done this before. 2nd time this specific stream, but I think 3rd time for this design. This should all be very familiar. And one more. All right. So, let's see. Smallest one is 3 millimeters. Next biggest one is 5.45. This is 5.45. This guy is a construction line, and this guy is 2 millimeters from that. Cool. Again, this is one of those things. The alternative here, instead of hitting equals, is to pattern this around. The problem is that I don't believe the mid plane set up in order to accomplish that. Fusion, thank you. And therefore, that is why we're not. And actually, again, because I'm just using equals right now, I don't need that guy. So if I had the mid plane set up right now, I would sooner just pattern this around, but since I don't have the mid planes or the center axis, which is the other option that I neglected to mention, and I will be deleting the circle before I do the next one, because obviously that is tying up resources and slowing us down, I am not going to bother. I'm not going to bother adding the midplanes and center line, is what that was in reference to. Center axis, rather. And we will just do it this way. Now, the orientation here does not necessarily matter, so I am going to arbitrarily say horizontal, vertical on these guys. And we are fully constrained. Nice. That guy. Why is that guy? Oh. That's not good. I'm guessing that guy was not fully constrained because... So are you fully constrained? Yeah, you're fully constrained. I'm guessing the other guy was concentric to the circle that I deleted is what happened there. So, let us go ahead and get these guys extruded. On the bottom face, we just have... Let's see. So we don't... the bottom face is hidden, and therefore we don't need to countersink these. Unless we want to. Yeah, I guess we do. I already have the circle in here. I was going to say, we actually don't really don't need to be countersinking these guys. But I've already went ahead and put the circle in here, so may as well. And that is the correct plane, yes, so -2. And then the through hole sketches. Actually, I'll hold off on the through hole and do that at the same time as the bottom of the center. Oh, the center shaft doesn't even have... Oh, derp. Okay. I forgot the center shaft doesn't have a floor to it. Nice. We're almost done. I already screwed up. Yeah. Derp. So this is a little bit of a annoyance because I am going to have to put more lofts into here. Other ways of doing this. We could put tabs. No, we don't want to put tabs on the top of the mounting plate because the mounting plate wants to be printed upside down right now. So we don't want to add stuff to the top of the mounting plate in order for it to key into and attach to the case. So I guess this is our life right here. Okay. In that case, this does now matter. It now matters. Okay, the other thing that I should be doing is I should be putting a hole in the center of this to get the wiring out of. Is the final thing that I should mention. Aside from that. Okay, aside from that, we are just going to have to loft some more stuff in order to make it printable. So, I guess we're on to that. I was excited to be done before the 2 hour mark, but... life does not always work out the way we want it to. Let me go ahead and put the hole in the bottom there. Just to get that over with. So project this. We can just center it on the bottom of this. That's fine. It doesn't have any specific requirements. We don't even have a specific size. So I'm just going to go ahead and make this Yeah, 40 is fine. I don't want to get too close to the edge, but that should be more than enough. Make that a construction. Make these guys constructions. Hit that. Extrude this through. Oh, that. I am in the wrong place right now. I'm in the center shaft right now. Control Z. All right. Come back down here to mounting plate. And really quick redo that. Extrude, distance all, flippity floppity, and make sure we're only cutting the mounting plate. Cool beans, cool beans. All right. Now we need to come back into this guy and redesign this guy is what we need to do. So let me turn the body back off, turn this guy back off, and we need to back to attach these to the wall, and then we're going to be lofting down. So we can loft down to the corner. That's not that big of a deal. Is that big of a deal? Yeah, all right. We're fine here. So I'm going to just grab these guys here. And this 6 actually is going to change now. I am now, because I have to attach to the walls anyway, make them tangent to the walls. This does get us awfully close to this edge. Hopefully this does not backfire to me. If this does backfire on me, what we can do is we can get rid of one of these lines. I don't know if it matters which line I get rid of, but yeah, and then we'll just change this to be centered so that this also comes over. So we can do that to shrink them in towards the center. But for right now, we're going to leave this as is and add in these guys exactly like we did before. There's that, there's that. And that looks like I have 2 lines here. Thank you. I was going to say thank you, Fusion, but yep, I do have 2 lines there. Thank you, Fusion. What? The weird thing is that didn't look like a right angle to me, but maybe I just skewed the camera a hair. Do. Alright, actually, since we're going back to the main body, I should be able to, let's take a quick look. Yeah, I do have a mid-plane going in that direction, so let me delete these guys up here. Whoops, delete. I deleted too much, evidently. There we go. And we'll just do these guys, and then we'll, again, mirror them across the plane, the mid-plane, the X-mid-plane, I believe is what it is. And then we should be good. Saves us a little bit of work because we already have the mid-plane intact. Now we can go ahead and extrude. Actually, let me make sure I'm in the correct object first. Center shaft, turn on, turn the walls off. And now extrude these guys. Okay, yep. So recall how I said that made interfere at this point? That is going to interfere at this point with these guys. So let's hop back over here. Again, delete one of these center lines and then recenter it. That on that, and then a center point to center on that. Okay, that. Let me see. That. Okay, I don't need any of these, frankly. We can delete all these. We're going to be using the, what you call it anyway? So what I can do, we're going to be using the center midplane to mirror stuff, so we don't actually need to be symmetric in that direction. So instead, I'm going to go ahead. There's a couple ways to do this, and probably the most straightforward is to do this perpendicular to that and click that on that. So I said this was like the most straightforward way. That is not entirely true. The more straightforward way would have been to collinear these two edges, but this is the way I've decided to do this. And then this 12 is arbitrary. Grab some water really quick. Alright. And we need all this for the time being, because we need to establish it first on the floor. Object that and 2 per our usual arrangement. And again, I decided I was gonna cut the holes. All right. We actually need to loft both sides, unfortunately, which is why I just stopped. However, we can do this in Sketch. We actually can loft it. We don't need to loft it. We can actually do this in Sketch. I just realized. These we change from right angles. I forgot. We're printing in the other orientation, which means that we actually need lofts perpendicular to where we're at right now, which means that I can take these and turn these into the lofts, and we'll be good. And this orientation does matter at this point, but this is the exact orientation we need for the hex nut orientation. So 45. It looks like on the other side we're not going to get away with 45 because it's going to run into this guy. So we might want to change this to 60, I guess. Whoops, that is incorrect. Or the other thing is we just need to move it in. So we have two options here. There's that, there's tangent. And let's see what that looks like at 60. 60 is still clipping that guy anyway, so let's move this. We're going to split the difference to, let's see. Alright, I'm going to up it to 50. Yeah, 50. We'll up it to 50, and then I will... do I want to project that guy down and do it off that? Yeah, I guess I do. So we technically could get a little bit closer to than this edge right here because this edge isn't doing anything. Actually, you know what? Yeah, let's try that first instead. Let's see how this looks. Let's go through that edge like that because in theory I don't think anything's going to be in the way right there. No, I take it back. Stuff will be in the way right there. Never mind. Bad idea. I have a lot of those. The good thing is that at least I have ideas. And one of these things, I copied the angle off of here over here, but the fact of the matter is that technically speaking, and this is only technically speaking, the equal sign works here. Once these things move, in theory, that equal sign could get screwed up and not work. So that equal sign could make this equal going in the opposite direction, is the potentially what could happen here when Fusion recalculates at some point. But I will cry about that when it happens. So we are in center shaft right now, so we are good to continue with our extrusions. I swear I clicked that. Distance, object, not distance, but start. -2. Okay. Do our offsets. And that did not work correctly. Face, face, face. Face, face, face. Minus 0.05. Okie dokies. And now I will go ahead and do the holes through everything. So let's include the mounting plate down here. Mounting plate body. Two-sided, all and all. Actually, no. The one side should not be all. So which side is this side? 10? Okay, that is that side. Good. So side number 2 should be distance to this guy so that we don't accidentally cut the roof. Okay, let me... Yeah, alright, we can come up here. Just to make sure we got that holes in there. We do. How did I... Is that a circle or a hex? Okay, that is a circle. I thought I somehow cut a hex in the bottom. We could turn this sketch off. Alright, and a mirror. We hit our mirrors, and we start mirroring some features. So that would be not that guy, but that guy, that guy, that guy, that guy, and that guy. And our mid plane is this guy right here. Okay. And there we go. Ooh, that's not how we go. Optimized. Optimized does not work. I swear optimized is just plain broken. It used to be that optimized always worked. And it seems like it is utterly broken at this point. So adjust. Like, I have not seen optimized work since a few updates ago. This is interesting. I wonder why it is not extruding the other guys. This is fascinating. Not even identical. It's oh wow. Okay, you guys ended up over here. That's why. Why did you guys? Huh? Where's my X mid plane? Huh? Let us. This does not make very much sense. Not that guy. This guy. And this guy. Let's start it off a little. No, let's just do these guys. Okay. We will do this a little bit at a time and see what happens, because that is a very, very weird behavior right there. Mirror, please. All right, that is, yeah, that is our join right there. So let us X mid plane adjust. The preview was right. The preview said it was putting it in the right position. Fascinating. Identical. All right, identical worked that time. It did not work before. Optimize. Optimize is, again, just plain broken. All right, let's grab the next one. Let's see what happens. Do-do, do-do-do, do-do-do. Do-do, do-do. All right. All right, I'm just going to grab the rest of them, and we'll see what happens. Okay, the rest of them did not work, but that is okay. Specifically, the hole in the center did not work. We'll grab these guys. I'm going to slide this guy backwards, and then I'm going to add the holes to this guy. It did not like that, but frankly, it did the correct thing, so... Yeah, okay, for some reason it brings them all the way over here. I don't know what Fusion is doing right here. Optimize worked this time. Are you kidding me? Optimize actually worked that time. Fusion, you so silly. Alright, well, okay. I guess that's a thing. Mic switch on, component base on. We'll go ahead and make another copy of this. Actually, I guess boundary fill this. Boink, boink. I wish it would automatically progress. I guess it's not. Okay. I was gonna say I wish it would automatically progress to the next step, but I guess it makes sense that you may not necessarily want that. Modify align component that guy. Actually, that guy to that guy. Okie dokies. And we can go ahead and toss a rigid group in here. That, and that. No. Okay. Well, I mean, I meant yes, but no. Alright, there we go. Everything moves together. Good. Alright. And that is the design complete. Alright. Yay. Oh, no. There we go. That's the design complete. Everything's still looking groovy. Double check. Let's take this handle. I can't take the handle off, so let's take this off. Alright, that's looking fine. Control Z. Let's take this off. That is looking fine. Fine. Okay, actually not so fine. The plate right here is not quite all the way clearing, so let's fix that really quick. And that should be everything else looking fine after that. So that is handle shaft, and that should be the last thing we did. Yep, it looks like it. And let's go up to 50 degrees. Okay. And that should solve it. That should be more than enough. Yep, it is. All right, awesome. All right. 2 streams. I guess that was close to 5 hours getting this guy done. I swear it sounded easier in my head. I guess part of it is because we did change the design from the little side knob, which is what I was thinking this morning before I remember that I said we might be alright doing a motorcycle throttle. So that is one more successful stream down. I'm pretty sure we don't have anything else we need to add to this, so I will get this printed out and assembled, and then we'll play some tooth and tail with it. The funny thing is that this feels like a little bit of overkill. This is going to be activating an ability that is kind of important, but one of those things is not necessarily. I guess it is core gameplay. One of those things, I only just started playing the game. I imagine it's core gameplay, but it's an ability that, okay, that's compared to our, so that's the size of it compared to our joystick. So let me grab the joystick, put it on the desk, and we could just take a quick look at what this is going to look like. Just plug the lights back in. Joystick. And camera action. Lights, camera, action. Alright, there's our joystick. Here are my hands. So you can see what the joystick is in comparison to their hands. Now let's hop back over to Fusion really quick. And that is the joystick compared to Fusion. So imagine my hand right there. And so they handle about yay big. We're looking like this. Maybe like that out to out of the case. So for your perspective, maybe something like that out to the case. So it looks like it's going to be definitely bulkier than this joystick. But hey, there's no buts about it. It's going to be bulkier than this joystick. So yeah, whatever. It's a fun device to have, and again, we can always attach another handle to the other side, and then we got a motorcycle for input. One of those things, though, this is a digital input at this point. For a motorcycle, we want analog input, so that would require some changes. Albeit, I'm trying to think of how hard So that would actually be a situation. You know what? We might be able to modify this afterwards to accommodate that. I'll think about it. Yeah. All right. Well, it's a start at any rate. Control Z to take that guy back out. We are on version 3 because we've done 2 streams. And like I said, I'll get this printed and then we'll get to look at it. So if you've stuck around for the full 5-ish hours that we've done designing this thing, thank you for sticking around and hanging out. And as always, look forward to the future streams. We now have this out of the way so we can move on to something else. And beyond that, I hope you have a great and wonderful day, afternoon, or evening wherever in the world. And I will catch you next time.